Hi, Silas.
Alright,
How are you tonight?
I'm alright.
All right. So we're going to do something new tonight, or are we going to review what we've been doing?
Well, I was a day ahead, so today in class we just started talking about completing the square.
So how'd you do? Was it easier?
I think I had a better grasp on it than most people, but it's still kind of a little on the weird side.
Okay. Shall we do some?
Yeah.
You want me to give you a few and let you try to do them?
Sure.
Or you can give me the problems also. It's probably more of a assurance that you know how to do them if I make them up.
Okay.
So let me make them up. First of all, do you get problems with coefficients in the x squared?
Yeah.
Yes, you do. Okay. And do you get problems that have fractions?
Yeah. Those are a little trickier.
Okay. Well, let's make up a good one then here to start with. So now you're completing the square to solve quadratics or to put quadratics into vertex format? Which?
We did both, but I can't really, it's hard to tell how to differentiate.
Okay. Well, the difference is that when I put something in vertex format, it's all on the same side. So I want to leave this 5 on this side of the equation if I'm going to try to convert this to that format. So let's do that first. And then I'll show you the technique where we would move that to the other side to complete the square. In other words, if we're merely trying to solve this when y is equal to 0, then it's a different matter. I move the 5 on the other side, and I just complete the square on this side. So there's two different ways to do it. Let's do this one like this. In other words, let's get this in vertex format.
Okay.
So what's the first thing I need to do?
Factor out 4.
Okay. What's this middle term become?
10/4 if we're keeping it in fractions.
Okay, let's reduce that to 5/2.
Okay.
And we're not doing anything with that -5, but putting it outside over here. So once again, it's always important to realize that at each of these steps, you haven't changed the equation. Notice that if I were to redistribute this 4, I'd get exactly the same thing I started with. Now we complete the square. So what do I need to write in this spot right here?
You divide -5/2 by 2.
Which becomes?
I don't know.
When you divide a fraction by a number, you can just put the number in the denominator.
Okay.
Notice that if I were to do it the more formal way, which is dividing by 2, or dividing by 2/1, now I'm going to flip this and multiply, so it becomes 5/2 times 1/2, so that's how the 2 gets in the denominator. Okay? But just know that if you're dividing a fraction by a whole number, you can put that whole number as a multiplier in the denominator. So it becomes 5/4 after you take half of it. And I'm ignoring the negative sign because I'm going to square it anyway, so it's not going to affect anything.
Okay.
Okay, so what do I write here?
5/4.
It's got to square it.
Oh, so 25/16.
And what do I have to write over here to balance out what I just did?
You'd have to multiply 25/16 times 4.
Okay.
And add it.
Okay. And I got to subtract it because I'm on the same side of the equation.
Okay.
Okay. So I have to subtract 25/4, which is what you get when you multiply 4 times 25/16. You get 25/4. But I got to subtract it because I'm on the same side of the equation. If I was doing it to the other side of the equation, I would add it.
Okay.
Okay, and if we're just solving a quadratic, that's what we're going to end up doing, is putting this number on the other side of the equation. So that's what makes for two different techniques, kind of. Okay, now what's the next step? Almost there. Remember, I'm going for this format right there.
You factor out.
Yeah, I guess you can call it that.
The x minus 5/4.
It's always the number that you got when you divided that by 2.
Okay.
Okay? So yes, 5/4 square. In other words, the reason I completed the square was so that I could write that as x minus some number squared. That was the whole purpose of it. Okay, and then what do we have over here?
Minus 5 and 25/4.
Which is 11 1/4. Because this is minus 6 1/4.
Okay.
And where's our vertex?
Negative 5/4, 11 1/4.
Positive 5/4 minus 11 1/4. Notice this format. It's x minus h. So when we got x minus 5/4, h had to be a positive 5/4.
Okay.
And k is plus k. We got minus 11 1/4, so k must be minus 11 1/4. Okay, now I'm going to do exactly the same problem, only we're going to do it slightly different. I'm going to say, don't put it in vertex format, solve it. Solve for the zeros. In other words, make this y equals 0 and solve this equation.
So we'd have 4x squared minus 10x minus 5 equals 0 is what we're starting with?
Yeah, but in this case, it makes more sense to take the 5 and put it on the other side.
Okay.
Okay? In other words, remember, I'm not going to solve this by factoring. I'm going to solve it by completing the square. There's a difference. Okay, so first thing I have to do is what?
Plug 4.
Room. So everything I'm doing is going to be exactly the same except the part about balancing out the equations. So what do I have to add here again?
It was 25/16.
Which, what do I have to do to this side over here?
Now you would add it?
Now I would add it.
Okay.
But not 25/16. 25/16 times 4. Because what I really did when I wrote that in there is I really added 25/4 to the left side of the equation, so I have to add 25/4 to the right side of the equation. Okay?
Okay.
Now, there's lots of uses for completing the square. So now I'm going to write this just like I wrote it before. X minus 5/4 quantity squared equals 11 1/4. Now what's the next step for solving this equation?
Divide by 4.
So now I have x minus 5/4 squared equals, what is that, 45/4 divided by 4 would be 45/16. Converting it to a improper fraction. Next step.
Do square roots.
Okay. What do I get on the right side when I take
X
this?
minus 5/4.
Well, hold on.
That's the left side.
Plus or minus, first of all. Remember to always do that because everybody forgets. And inside is 45/16. Now, the final step is going to be to move this 5/4 to the right side of the equation and we'll have our answer. But before we do it, we can simplify this radical. Let's simplify that radical first. First step in simplifying it, square root of 45 over square root of 16. You see how that's different?
Yeah.
Okay, I've just broken it up. Square root of 45 is what?
6. It's a decimal.
It's 9 3. We're not going to convert it to a decimal. We're going to leave it in radical form. Excuse me, I didn't do that multiplication right. It's 9 times 5. And square root of 9 is 3. So root 45 is the same as 3 root 5. So now, after simplification, we have x minus 5/4 equals plus or minus 3 root 5 over 4. So we're going to add 5/4 to both sides. And there is our answer. And notice we did something completely different. Both techniques. We used completing the square the first time to put the thing in vertex format, and the second time we used it to solve for the zeros. In other words, we changed the y to 0, which means I'm solving for the zeros of this function, which means you're solving for the points where it crosses the x-axis. And I used completing the square. I could have used the quadratic formula, notice. In other words, normally when you're solving a quadratic, you do put everything on one side and 0 on the other, and then you try to factor it, and if you can't factor it, you use the quadratic formula. Well, the third way to solve a quadratic is the way we just did it. In other words, we didn't factor it, we didn't use the quadratic, we completed the square. And in order to complete the square, I had to put that number on the other side.
Okay.
And then completing the square will be used when you get to conic sections. Circles, ellipses, all of that. So completing the square is a very common technique to use. Notice the answer I got was very similar to what you get when you use the quadratic formula. If I had used the quadratic formula, I would have gotten 5/4 plus or minus 3 root 5 over 4. Looks like a quadratic formula answer. And that's exactly what we would have gotten. Okay. What shall we do next? Shall I give you another one and have you choose? I'll give you one more and I'll have you do 2 things to it. And if you can do both of these things, you got this down pat. One is put it into standard format, and the other is to solve it. So let me make one up. Make it a little easier this time. Now let's change the number. Make it a 7. So first of all, let's put it into vertex format, which is standard format also.
Okay.
It's actually not standard form. I just realized standard format is ax squared plus bx plus c equals 0. Yet vertex format is something totally different, and I just saw in a test the other day that somebody showed me that they asked for standard format and they meant vertex format. So when I say vertex format, I mean this format, where h and k represent the vertex of this quadratic. Okay, so how do I begin?
Factor out 3.
Read the line for me.
What do you mean?
Read the entire line. When you factor out 3, that doesn't really tell me what you get as a middle term. So.
Oh. That leaves you with x squared minus 3x.
Okay.
And you would take 3 divided by 2.
Okay.
Gives you 1.5. And then you square 1.5.
Okay. You could square 3 halves. In other words, you can leave it as a fractional format. It might be easier, actually.
I guess we're leaving it 3 halves?
I do, because then when you square it, you get 9/4, which is almost easier. It's easier to square 3 halves than it is 1.5. Agreed?
Okay. So then you get 9/4.
Okay.
You have y equals 3x squared minus 3x plus 3 halves.
Not plus 3 halves, plus 9/4. But I haven't done one vital thing. In other words, before we started, this was the equation. I can't arbitrarily write in numbers like that. I've changed the equation.
Or subtract it, don't we?
What do we have to do?
Don't we have to subtract
How much?
the 9/4 times 3?
Yep. So I'm going to subtract 27/4, like that. Now the equation is the same.
Okay.
Now how can I write it so that it looks closer to that?
Y equals 3x minus 9/4.
Not the 9/4.
The 3 halves.
Yes. Because remember, we're squaring it. If you were to square this, your final term is going to be that 9/4.
Okay.
Okay. And then the rest of this is 4 goes into 27, 6 3/4 times. So that's 13 3/4. Notice how everything was actually a little easier if I left it as an improper fraction rather than converting to a decimal.
Mm-hmm.
Just it worked out that way. And that's vertex format.
Okay.
What's the vertex?
Would be 3 halves, negative 13 3/4.
Good. Okay, now let's take the same problem and solve it for the zeros. solve that. And let's assume that it doesn't factor without trying even. I mean, it might. I don't know. I made these numbers up. But it doesn't matter. Let's solve it by completing the square.
Okay. So we add the 7.
Okay, so now I'm going to switch the things also,
Yeah, I did
which
that.
obviously doesn't have any bearing on it, whether I write the 7 on the left or the right side of the equation.
And factor out 3. Which leaves you with x squared minus 3x. Then same thing, you do 3 divided by 2, 3 halves, then you get squared, be 9/4.
Now what do I do over here?
9/4. You add, what was it? It was 27/4.
Uh-huh. So now let's continue.
And then divide it by 3.
Not yet. Well, yeah, I guess we could do that. It doesn't really matter. But the primary thing is we want to represent this as x minus something squared. So let's do that while we're thinking of it.
Okay, then
You'll
be
see.
x minus 3 halves squared.
Equals, let's see, we have 28/4 and 27/4. Sounds like 55/4. Okay? Now we divide by 3. We could have done it in either order,
Okay.
but it's more logical at this point. Because now we can see that if we divide both sides by 3 and then take the square root, I'm going to be able to come up with an answer for x.
Okay.
So dividing this by 3, remember I said you can just put the 3 there.
Yeah.
So now we have x minus 3 halves squared equals 55 divided by 12. So next step.
Then you would do square root.
Okay, so next line reads how?
X minus 3 halves equals 55 divided by 12, all divided by 3.
No. Taking the square root of 55 divided by 12.
You do plus
But
or
what
minus.
did I forget? Plus or minus, exactly. And notice that really makes a difference. If I forget the plus or minus, I'm only going to come up with one solution, not 2.
Mm-hmm.
And every quadratic has 2 solutions. So can I simplify my 55 over 12?
Not to a whole number.
No, but I can simplify it.
Okay.
And it's kind of a difficult simplification, so let's go through it. That would be good practice. Let's just go down here and help me simplify that. What's the first step?
Square root of 55 divided by square root of 12.
Okay, doesn't look like I've done much, but I have because I can work on the square root of 12. What's the square root of 12?
3 now.
Yeah?
Square root of 3, square root of 4.
It's exactly. Square root of 4, square root of 3. Square root of 4 is what?
2.
So it's 2 square roots of 3. Still have this 55 up there. Now what's the problem with this answer? It's got a square root in the denominator.
Rationals in the denominator.
How do I rationalize that?
Wouldn't you, I forget.
Multiply it by the number 1, only what number 1 am I going to use?
Oh, root 3 over root 3.
Exactly. So now I have root 165 over what?
165 over 2.
It would be 2 times square root of 3 times square root of 3. Square root of 3 times square root of 3 is 3. So it's 2 times 3.
Okay.
That's almost my answer. That's what this is. And it may not feel like it's simplified, but it is. So now I have x minus 32 equals, let me erase this with square root of 165 over 6. And now what?
Add 3 halves.
And put it in front, not afterwards. In other words, let's make it... Yeah, you know, it really doesn't. The only reason I say do that is because if we use the quadratic to solve this thing, we're going to get the answer exactly like that.
Okay.
If I put the 3 halves here and somebody wants to check the answer with the quadratic, first of all, you got the plus and minus in front, so it doesn't look like... Short answer is no, it doesn't matter, but
Okay.
it fits the form better.
So
Same number.
I won't. Well, on the vertex form, you put it at the end, and I always just put it before plus or minus. I'm not going to get like marked down for that or anything.
Well, on the vertex form, you have
Unless
to put it in this format for the vertex format. So it does matter. In other words, you have to end up with it looking like that. When you solve the equation for the zeros, no, you're not going to get marked down if you put the answer like this.
Okay.
You might get marked down if you put the answer like this. In other words, you're supposed to simplify all radicals and make sure you don't have a radical in your denominator. Remember that a radical is always an irrational number if it doesn't turn into an integer. Every radical of a number that does not become an integer is irrational. Okay. Well, feels to me like you understand that stuff pretty good. Are you going to have a quiz on this material shortly?
I think next week, maybe.
Okay. All right. So, let's see. You guys schedule online, don't you?
Yeah.
Or
So.
no, maybe not. Hold on. I think your mom. Oh, your mom is scheduled like a month of sessions, so we're scheduled for next week.
Okay.
I think. Let me just check here. Yeah, she's scheduled half hour Monday, Tuesday, and Wednesday.
Okay.
Talk to you Monday night.
Okay.
Have a good weekend.
Yeah, you too.
Bye-bye, Si.
Bye.